When we do hybridization, we start again with these 4 atomic orbitals. These are the original orbitals of our atom, and again we're talking about second row elements. So what we have an S, px, py, and a pz. And once we do our hybridization, we will get out 4 atomic orbitals. So the number of orbitals will be conserved. Now, these will be some combination and mixture of our 4 atomic orbitals that we put in, our S and our px and our py and our pz. So what are the 3 different ways that we can do hybridization? Well, I'm going to write 3 different ways, and I'm just going to write S and 3 p's 3 times, because that's what we need. Great. So in our first option for hybridization, we can mix an S and a P, and we will always start with an S orbital when we do hybridization. We can mix our S orbital with just one of the P orbitals. So we start with 4 orbitals, S and 3 P's, and we're going to get out 4 new orbitals over here. 2 of those orbitals are going to come from mixing our S and P, those 2 particular atomic orbitals. So we will get 2 different sp hybrids. 2 orbitals in, mix them together, and we get 2 orbitals back out. And they are sp hybrids. And sp indicates that each of these orbitals is called an sp hybrid, and each has 1 part S character and 1 part P character. Now, I haven't addressed the fact that we have these leftover p orbitals that we haven't hybridized. Well, they come along as well. So they are left over at the end as simply 2 unhybridized p orbitals. So we put in 4 atomic orbitals, the S and the 3 p's, and what we get out? We get 4 atomic orbitals, 2 of which are sp hybrids, here are hybrids, and 2 unhybridized p orbitals. Let's go through the same logic down here. Now we're going to take our S orbital and we're going to mix it with our 2 p orbitals. And so now the new hybrids are going to be called sp2 hybrids. That's a superscript. And we put in 3 orbitals to make the hybrids. So we get out 3 of these sp2 hybrids. There's a leftover p orbital, and so there is 1 p orbital left over. 4 orbitals in, 4 orbitals out. 3 hybrids, 1 unhybridized. Let's try this one last time. Now, the last option is to mix our S with all 3 p orbitals. That's going to give us 4 hybrid orbitals, and they are going to be called sp3 orbitals. 4 sp3s. Plus, we don't have to write this down, but we're going to have 0, put a slash to it, that's not an O, that's a 0 p orbitals left over. 4 orbitals in, 4 orbitals out. So there are 2 ways, there are 2 items for hybridization we need to keep track of. We need to keep track of the number of attached items, and let's not call that items, let's call those atoms. The number of attached atoms to our central atom. Remember, when we do hybridization, we are assigning the hybridization of a central atom that's bonded to other atoms. So how many atoms are attached or bonded to our central atom? Let's call that A. And then we also need to keep track of how many lone pairs we have on our central atom. As it turns out, the minimum number of hybrids that we need to make is going to equal to A, the number of attached atoms. Because notice, we have options on how many hybrids we make. We can make 4 or 3 or 2 hybrids. Well, we need at least A hybrids. That corresponds to the number of attached atoms. And the maximum, having all kinds of trouble here, the maximum number of hybrids is going to be the number of attached atoms plus the number of lone pairs. Now, to really bring home these examples, we're going to have these different cases. We need to look at some examples, which we will. But this is the idea for hybridization. We have different available hybridization schemes, and for these hybridization schemes, we'll use the number of attached atoms and lone pairs to determine how many hybrids we need. And once we know how many hybrids, then we look, okay, I need 3 hybrids. Let's think about sp2 hybridization. But we'll see examples on how to apply those.